In this next exercise, we're going to write a facade script that makes it easy to convert a markdown file to a PDF file and gives us something that feels like a program that's built into our shell, right? Or on our system. And we're going to effectively write a facade over the pandoc program. And remember, pandoc makes it easy to convert files between two different formats. So we're going to have an input file of a markdown file and an output file of a PDF file. Our goal is to be able to run a command that looks like this, md to PDF, and then we just give the base name of the file. We don't have to give an extension, and it will run this pandoc command above. So go ahead and pause the video here, work through the next set of steps on this slide, and then we'll pick up from where we left off. Okay, so I've gone ahead and followed through these steps as well. And my markdown file looks something like this. So I named this demo.md, and I've just got some annotations for a heading 1, a paragraph, a list of text, and another paragraph, right? And then put that in file demo.md. I've got my md to PDF script here. So notice we've got the hashbang or the shebang line. We've got a variable being set up named file, and we are running the command substituting that value in, and we're reading the file from the very first argument of this script, right? So now, in theory, if I run md to PDF, I also change the executable permission, of course, and give a file base name of demo, and press enter. In the Unix tradition, there's no output, which gives us some sense that this worked. So if I ls again, notice there's a demo.pdf file. And if I were to go look in this directory on my host machine, here's my demo file. And if I open it up and resize this so you can see it, sure enough, there's my generated PDF file from my markdown file. Pretty cool, right? So we've got a simple script here that we could call a facade script. We can run this program and see that we are effectively proxying to the pandoc program via this simple shell script. But we have some limitations here, right? If I just ran md to PDF, we get like a weird error. It says there's the nothing.md doesn't exist. So what's going on there? How can we improve our script so that we are a little bit more that we give a better user experience to someone trying to make use of it? If they didn't know how to use it, maybe we should print out some help information, right? So in order to do that, we need to know how to make use of conditionals to test whether or not some condition is true, such that if you didn't provide a first argument, then we would give you a help message and not try and run the program. Or if you did, then we would instead run the program. So the syntax of if then else is a little bit funky in Bash, but hopefully won't be too far-fetched. We use the if keyword followed by some command, and we'll talk about what this command evaluates to for this to be truthy or falsy. And then we have the then keyword, whatever happens in the then body. We have the ability to give else if branches. So else if we would test some other command. Notice that we're just collapsing those two words and shortening them. We have an else branch that's possible as well. Both the elif and else are optional, of course. And then my favorite design decision is the way that we end an if statement in the Bash language is we do fi, which is the opposite of if. So this is the closing tag for an if statement, right? And how do these commands work? So notice we're saying if is some command, then. So this is actually a shell command that we're going to have to put after the if statement. And in order to understand what kinds of commands we can put there and how to interpret the evaluation of that if statement, we need to understand exit codes. So whenever any program exits, it generates what's called an exit status code that you can use to know whether or not that program succeeded or failed. Traditionally, if a program succeeds and it exits normally, it's going to have an exit code of 0. So in a somewhat unique to Bash and very different from most languages convention, 0 is going to be our truthy value in an if-else statement, right? Non-zero exit codes means that some exceptional case occurred in the command that we ran, and that means that we should treat it as if there was an error, right? So what happens is bash is going to store the exit status code in a special variable that we can access via the question mark. So the question mark is the exit status code of the last command we ran, right? So we can try this out. So if we run ls and then echo what is in our last exit code. So notice the ls command ran and succeeded. So it gave us an exit status code of 0. However, if we ran some program that doesn't exist, command not found, and then we tried to echo, well, what was the exit status code of that? We would see that we get 127, which is an error status code. And so if a program errors, it tends to give a non-zero status code. One of the things I should mention is the manual page of a program. When you say, for example, man grep, and if I were to search for exit, we would see here, there's a section of the man page that says exit status. Normally the exit status is 0 if a line is selected, meaning if there was at least one match. 0 is the exit status of grep. 1 if no lines were selected, and 2 if some error occurred. So notice that 0 is the success, like we found something we were looking for in a file. 1 tells us there were no matches, and 2 would say that there was some kind of error that occurred. Right? So each program is going to tell you a little bit about what its exit status codes mean if there's anything more nuanced than 0 is success and some other non-zero number is failure. Often in shell scripts, we want to test conditions such as, hey, is this variable set? Or is it equal to the empty string? Or is it equal to some string we're looking for? And there's a built-in program that is standard in the Unix libraries or Unix systems that you'll use called test. And it will allow us to do things like compare two strings. It will allow us to check and see, hey, does a file of this name even exist? Or a directory of this name exist? We can use it to form complex Boolean expressions, which we won't get into today. We're going to look at some of the more simple cases of it. You can look at the different kinds of tests you can do in man test, right? So the manual for the test command is test followed by some expression. And if we were to look, we can see that the expressions we can evaluate are things like -z followed by some string will return 0 if the length of the string is 0 and 1 otherwise. We can test if one string is equal to another string with a single equal symbol. And there are some others that you can see in the documentation of the test program. So here are some examples. We can say test is the path equal to PWD. And if we looked at the exit status code, we would see that they are not equal. So we would get a non-zero result. So is path equal to PWD? Oops, and I should have run the test program, not echo. So that was what was the input would be. So if we were to run test here, notice there's no output. So I run test, and then if I echo what was the exit status code, it's 1, so it's non-zero. But if I were to test is path equal to path, and we look at the exit status code, it would be 0, meaning that that was a successful exit of this program, which we could use in an if statement to use as a truthy value, right? It's important, white space is important here because this test program is just a program, right? It's located at user bin test. And just like any other program we're executing, like echo and even the script files that we're writing today, we have to separate arguments that we're passing to that program with spaces. So test is going to be given 3 arguments, which would be 3 strings. And what it's doing is it's looking through these and using some logic to decide, well, what type of test are you trying to perform? And in this case, when it found a string followed by this equal symbol, it knows we're trying to test, are these 2 strings equal to one another? It turns out that writing code that looks like, if test path is equal to something else feels a little bit funky and clunky, right? In programming languages, we're used to writing things like if and then some statement in here. And so in a true demonstration of cleverness, the shell script folks who the people who made the bash shell script set up an alias for test that is the open square bracket, right? So open square bracket is an alias for the test program. So these two things are going to do the same thing. And rather than writing if test foo is equal to bar like this, what we'll be able to do is use this alias to write if followed by an open square bracket, which is, again, just the same as test. There's no difference here, followed by the arguments that we're passing to this program test, that is the symbol open square bracket. The only difference is that it does enforce that you use a closing square bracket argument as the last argument, right? But because these are arguments as well, you have to be careful of white space and to be sure they're separate from one another, which is kind of funky, but also kind of clever and a cool trick. Right? So this allows us to write if statements that look a little bit more natural, but remember what's actually going on under the hood is you're evaluating a program named test that's a command, and these are the arguments you're passing into it. Right? So what I'd like to do next is have you pause the video here and try extending your implementation of MD to PDF to use a few if-then statements, and we'll talk about what each of these conditions does in just a moment. Okay, so if you haven't tried using this program and seeing if you can run MD to PDF with these modifications and causing each of these error messages to print, I would encourage you to try doing that as well. Great. So here is my implementation of this simple little script file. And what we can see is happening here is this first if statement is checking if the length of this string after we substitute in our file variable is 0, right? And so one way of checking whether or not someone provided an argument here is just to see, well, is there any value in this file name? We need to have a non-empty file name. If so, if it is empty, then what we're going to do is print out a little help message here. The way that you use this program is MD2PDF followed by the file name, and then we're going to exit with a status code of 1. And remember, if we exit with a status code of 1, that means this program terminated in an unexpected way. This is not a successful exit when we exit with a value of 1 or some other non-zero number, right? Similarly, after we say, okay, well, they definitely gave us a file input name, but is that actually a file that we have and we would expect to be in our directory here? So here we're testing if it is not, using the exclamation point for not. And again, that's an argument. So we need it to the test program that is this open square bracket. So we need spaces between these things. And then the next argument is this -f modifier, which is saying whatever follows me, check and see if that's a file. And then we're going to not that. So if it's not a file, then we're going to print another helpful test message, which is, hey, you're missing the file, and then the file name that you tried, .md, to say, here's the file name we were looking for. Also going to exit with a non-zero status code there. And lastly, if those two conditions are met, we should just go ahead and try running our Pandoc program. All right. So I'm going to save this and let's try it out. So let's try the first case, MD2PDF, and notice that what we got here, because we didn't provide a first argument, was some helpful information on how to use this. We didn't try and run Pandoc or anything like that. If I ls here, we can see that we don't have a file named foo.md. So if I tried md.pdf foo, we would then get the second error case that was also trying to be a helpful error message saying, hey, you're missing the file foo.md. So what if I copied demo.md to foo.md? So now I've got this foo.md file, and if I tried that command one more time, md to pdf foo, hey, it looks like it worked. There's no output there telling me there was an error or anything like that. If I list my files here, sure enough, now I have a foo.pdf file because we ran that script, which dispatched out to the Pandoc program in order to generate foo.pdf. And if I looked in my Windows Explorer, we would see that sure enough, we've built another PDF from that foo file. Right? So in this video, we looked at how we can start extending a script beyond just running a sequence of commands that's always going to be the same every time, such that we can have some conditionals. Next up, in a future video, we're going to be looking at how can we have loops to loop through, say, and carry out some action on all files in a directory. And we'll also look at how can we have functions to add some structure to our shell scripts, and look at some more advanced concepts that we'll see in terms of string interpolation.